Hi there. All right, welcome to your pre-lesson video on expressions, equations, and formulas. We'll get started real quick. So, expressions are essentially one side of an equation and it normally doesn't equal something. So it'll be like, oop, hang on, let's change this. There we go. All right, so it'll equal to like 2x, 4y, 3x plus 4y. 2 over 3x plus 4 over 3x. So as you can see, these don't equal to anything, and these are what we called expressions. All right. Now an equation, all right, such as x equals 2, x plus y equals 2, 3x plus 4y equals 2, 2 over 3x plus 4 over 3y. Right? Now, as you can see, an equation is a pair of expressions that are equal in size, meaning one side equals to the other side, and we can solve to find what these are later down the course. All right. Now, system of equations is two or more equations in a single instance, and we're trying to find out what their respective values are that will make them equal. For example, let's take 4x plus y equals 6, 2y plus 3x equals 1. And then we would need to solve this in order to find the values of x and y that would satisfy both of these equations. And we'll learn that in a bit. All right. Now the next thing that we have are unknown or variable. So an unknown or a variable is a number that might not be known and is typically represented by a letter, usually X, but it can be honestly any other letter. So the letter could represent, a fixed value, whether only one value solves the equation, such as X equals 2. We know that X has a fixed value, which is 2 in this case. All right. Or the unknown or variable, it can represent a changing value where two or more values solve the equation. For example, let's look at y squared equals 9. We don't know what y is, and this is our unknown or variable. But we do know after solving it, we actually have two values. So y would be -3 or 3. So as you can see, it has two values in this case. In some instances, it can have more than two values. All right, so essentially an unknown can be any letters, and we'll actually go through that in the table down below. It could be any letter. It could be like A, B, C. Normally we leave I as an imaginary number, so if you want to use any other letters besides I, that's fine, right? So like I said, an unknown variable can be any letter. Now, coefficient is the quantity of like unknowns. So let's take the example of 3x. 3 in this case will be the coefficient because it tells us that there are 3 x's, right? Now let's take 12 over 5y. 12 over 5 here will be the coefficient because it tells us that there are 12 fifths of y's. All right, so essentially coefficient will be the number that's in front of the unknown or variable. Now let's look. So some common variables and their meanings. It's good to understand and know what these are because they will come up very frequently as we go through the course and in any of the other math classes that you have taken or will be taking in the future, right? So x and y are generally known as the coordinates of a point on the rectangular coordinate plane and they're normally written in this format, x, y, right? Now, m and b are the slope and y-intercept respectively of a linear equation, with m being the slope and b being the y-intercept. And normally it's like in y equals mx plus b. And then h and k, right, so they are the x and y positions respectively of the center of a circle or the vertex of a parabola. And we'll actually get into more detail on this further down the line. So like h would be the x value and k will be the y value. All right. And now another thing that k is, right? So k can also be a constant, which is a number that doesn't change. So if we look at this equation, y equals kx, k in this case is a fixed value. It doesn't change. All right. The next thing we have is I, which is the imaginary number square root -1, which is a number that cannot exist in real math. So square root any negative number would not exist, right? It's not real. It doesn't exist in real math. If you were to ever plug in square root a negative number, you will always get math error in your calculator, right? And we would denote this as we're doing math as I. All right. And now, A, B, and C are the coefficients of a quadratic equation or the sides of a triangle. We'll actually get into a bit of this down the line. And then here, the special symbol pi, right? So pi represents the ratio of a circle's circumference to its diameter, and it's roughly about like 3.142 or 22/7. So it's like a fixed value. And now this is theta, and this is how you spell it. So Theta. It shows the degree measure of an angle. All right, so these are some common variables and their meanings, and it's really useful to remember what these are. All right. Now, combining like terms. When we combine like terms, we want to make sure that they have the same variable in order for them to combine, right? So like 4x plus 3x plus 2y equals 5. If we look, right, 4x and 3x, they are what I call, they are the same species is what I would call them, right? So 4x and 3x are one species, 2y is another species, and 5 by itself is another species, right? So anything with x is one species, anything with y is another species, and anything that doesn't have a variable or just a whole number by itself, like 5 in this case, is another species. And in order to combine like terms, they have to be the same species. So we can do 4x plus 3x, which would give us 7x plus 2y, right? We're just writing 2y because we did not do anything to it, so we're just dropping it down. And same thing with 5, right? So once we combine the like terms, we get 7x plus 2y equals 5. Now, if you notice, 4x plus 3x are on the same side of the equation. They're both on the left side of the equation. So then that means we would just operate on it like usual. Now let's look at the other instance where they are on different sides of the equation. Let's take 7x plus 3y equals to 2x plus 3. Okay, so you look here, 7x and 2x are the same species, 3y is another species, and 3 by itself is also another species. So we have 3 species altogether. Now we need to group the like terms, which are 7x and 2x, but they're on different sides of the equation, all right? So let's decide where we want to bring it. So in this case, I want to bring 2x over to 7x. In order to do that, I need to get rid of 2x on the right side of the equation, right? So let me rewrite the equation again. Right, so because we want to get rid of 2x here, we need to do the opposite of how it is right now. So we have positive 2x. In order to make it become 0, right, equal to 0, we need to subtract 2x there. And because we subtract 2x there, we would need to also subtract 2x on the opposite side of the equation under its like term. So 7x minus 2x, all right? And then from here, that will give us 5x plus 3y, because we didn't do anything to the 3y, right? So we're just dropping it straight down. All right, and then we have 2x minus 2x, that's going to equal to 0, which is what we want. All right, so we don't even need to write it. And then 3, we didn't do anything to it, so we're just dropping it down. All right, and so that's how you combine like terms if they're on different sides of the equation. You want to do the opposite of how that term is acting on the side. All right, if you have any questions about this, bring it to your deep dive lesson. Now, the next thing that we have is distributive property. So when we are distributing stuff, say we have 2 times x plus 3. When we are distributing stuff, we want to multiply everything. We want to multiply the outside with everything that's in the inside, right? So in this case, we're going to do 2 times x, which is going to give us 2x, 2 times 3, which is going to give us positive 6. So that's going to give us 2x plus 6 after we distribute 2 times x plus 3. All right. And now the other thing that we need to take important notice of is if we have a negative sign. So let's take negative 4 times 5 minus 6y, right? Again, we need to multiply everything. We need to multiply the outside with everything that's in the inside, right? So negative 4 times 5 is going to give us negative 20, right? Because negative times positive will equal negative, so we get a negative number, right? And then we need to do negative 4 times negative 6y, which is going to give us positive 24y, right? Because negative times negative equals positive. And so after distributing, we will get negative 20 plus 24y. So just when you are distributing, take very good notice of the sign that's in front that you have, all right? And now it's a combination of both distributive and combining like terms. So what we want to do in this case is we want to first distribute it, all right, before combining. So we need to do 4 times 3x, and then 4 times 2, and then negative 5 times negative 7x, negative 5 times negative 9, right? So let's do 4 times 3x is 12x. 4 times 2 is positive 8. Now negative 5 times negative 7 is going to give us negative 35x. Negative 5 times negative 9 is positive 45. All right. And now the thing that we want to do is combine the like terms. So let's determine 12x and 35x are our like terms. 8, ooh, that meant to be pink. There we go. There we go. 8 and 45 are our other like terms. So we want to combine the like terms together. And so let's do this. So 12x plus 35x is going to be 47x. 8 plus 45 is going to be 53. All right. And so once we have expressed the expression completely, because that's the normal instruction that they generally give, right, for these type of questions, we are going to get 47x plus 53. All right. All right. Now on to the next thing, two-step equations. So with two-step equations, it is like expressing the expression completely, but you want to solve it for a variable. So in this case, we want to solve it for y. So it means y would equal something, right? So first thing we need to do, as you can see, we have to distribute the parentheses. So we're going to drop 6 because we're not doing anything to it. So 6 equals 2 times y. 2y, 2 times 2 is positive 4. So after distributing, our equation now becomes 6 equals 2y plus 4. All right, and then if you notice, 6 and 4 are like terms, and let's make 2y by itself, because in the end, we want our solution, right, to be y equals something. We want y to be by itself by the very end. So let's get rid of positive 4 here. To get rid of it, we are going to subtract 4 on that side of the equation, and because we're subtracting 4, we need to because we are subtracting 4 on the right side, we also need to subtract 4 on the left side, right? So now we do 6 minus 4 is 2. And then this 2y, we didn't do anything to it, so we're just going to drop down, so it'll be 2y, right? Now as you can see, we want y by itself, but 2 is being multiplied to it, right? So we want to do the opposite of multiplying in order to get rid of the 2. Because 2 times y, we need to divide both sides. We need to divide this by, oh, that's not supposed to be a negative sign. Whoop. We need to divide this by 2 in order to get rid of the 2 and make y by itself. And because we divided 2 there, we also need to divide 2 here, right? After that, we're going to get 1 equals y, right? Because these cancel out, which is why we divided both sides by 2, because we want to get rid of this and make y by itself. And so then our solution is going to be y equals 1. All right? And the next thing that we have, equations with fractions. So normally when people see fractions, they're like, oh no, it's a monstrosity. First thing you need to do when you have fractions, we want to get rid of it. And how we can get rid of it is we can cross multiply in order to get rid of the fraction. And so from here, we're going to get 4 times g plus 5 equals to 3 times 9 minus g. Again, we're going to distribute the parentheses. All right, so we have 4 times g, 4g. 4 times 5 is going to be 20 equals 3 times 9, 27. 3 times negative g is negative 3g. All right, again, as you can see, we want to combine the like terms. All right, so let's do the g's first. I want to get rid of negative 3g on the right side of the equation, and in order to do that, I'm going to add 3g to both sides. So that's going to give us 7g plus 20, because we didn't do anything to it, so we're just dropping it straight down, equals to 27. Same thing, didn't do anything, drop it straight down. All right. Now I want 7g to be by itself, because in the end, I want my solution to be g equals something, right? So let's isolate 7g by itself. In order to get rid of 20, we need to subtract 20 on both sides of the equation, right? Because we want 20 to equal to 0. From there, we get 7g equals 7. Again, we want g by itself now, right? So we need to get rid of 7 that is being multiplied to g. So the opposite of multiplying is divide. So we need to divide both sides by 7. This gets rid of it. And so now we have g equals 1. And that is our solution. All right. So as you can see, with solving equations, it's a lot of like distributing and combining like terms. All right. Now moving down. Look, same thing with fractions, but this time, as you can see, their denominator is not common. So we need to find their lowest common denominator, right? So in your previous module under fractions, we learned how to find lowest common multiple. Same concept, just now it's for the denominator, right? And so I already found for you in advance the LCM, or the lowest common multiple, of 3, 7, and 2 is 42, right? So now, let's see. Now we need to make this all have the same denominator. So let's look. 3 times what is 42? So let's quickly check. So 3 times 14 is 42, and I'm going to write my x here, plus 2 times 6, 7 times 6, that will equal to 42, equals to 1 times, I believe 20, no, hold on, yeah, 1 times 21, 2 times 21, solve all this first, that's gonna give us 14 over 42x, yes, I also write my x like this, plus 12 over 42 equals to 21 over 42. All right, and as you can see, 14 over 42x is its own species, and then these two others are they're the same species. So let's group these together. So I want this to be by itself. So we're going to subtract both sides by 12 over 42. All right, and so I'm going to move that all up. And so now 14 over 42x equals to, let's see, 21 over 42 minus 12 over 42 is going to equal to 3 over 14. All right, and now we want to get rid of 14 over 42 because we want x by itself. So what we could do here is we can multiply 14 over 42 with its reciprocal, right? So we're just going to flip the number, 14 over 4, and since we did that there, we're also going to multiply this side with the reciprocal, right? So then these cancel out each other, so x would equal to, let's see, 3 over 14 times 42 over 14 is going to give us 9 over 14. And that is our solution. All right. And now this is combining everything, but now we have to distribute with fractions. So same thing, half times x is half x, half times 2 is going to be positive 1, equals to 1/4 times x is 1 over 4 x. There's the same thing. All right, and then 1 over 4 times negative 6 is going to give us negative, let's see, negative 3 over 2. All right, again, let's combine the like terms. So let's subtract negative 4x here, negative 4x. So half minus a quarter is going to be quarter x plus 1 equals to negative 3 over 2. I want this by itself, so subtract 1. So now 1 over 4x equals to, let's see, negative 3 over 2. Next one. That's going to give us negative 5 over 2. Multiply both sides by the reciprocal of 1 over 4, which is 4, right? So multiply this by 4. That means x equals to negative 10. All right. So same thing, distribute as how you normally would, and then solve from there. One way to check your answer if it's correct is plug in the value that you find and see if it equals to each other, right? So if let's say I were to take this here, plug in negative 10, it should give me this should equal to this, right? Plug in negative 10, plug it to negative 10. Let's say, so half, so negative 10 plus 2 is negative 8. So all this negative 4, this should also give me negative 4. If they both equal, then your answer is correct. If they don't, let's say you get negative 4 here and negative 5. That means this is not the right answer and you will need to solve it again in order to find the correct one. All right. And now, absolute value equations. Fun. So now with absolute value equations, you would have to do this because we know that it's the distance from 0. We can write, we would have to write our solution like this. So we have x plus 2 equals 9, or x plus 2 equals negative 9. Right? You need to do this in order to solve it. Now, again, from here, we're going to combine like terms. So we have on one side, x equals 7. Solve it here. So x with negative 2. So x equals negative 11. And so that means our solution is x is negative 11 and 7. All right. So yes, for absolute value equations, this would split it into 2. Now, a big thing to remember before you even solve it, which we may see in our homework and quiz, is that if, let's say, the equation is like x plus 2 equals negative 9, because this is negative 9, that means it has no solution because all absolute values must be positive. Understand? So instantly, if you see like this is the absolute sign, you haven't opened it up like this yet, but so absolute sign still here, you get a negative number, no solution. All right. If you have any questions about this, bring it to the deep dive lesson. And so now we look at this. Looks monstrous. Don't fret. So let's look. Let's bring our, actually, if you want to look at this, see how these two absolute signs are the same? That means these are our same species. So let's take it as like 7x and 5x. All right, and then negative 10 are another species. So let's actually get rid of the negative 10s first on one side, right? So let's do plus 10. That's going to give us 7x minus 3 equals to 5x minus 3, right? And then negative 10 plus 10 is going to be 0, so we don't even write. So now, oh look, they're the same, right? Same species. We can actually bring them to one side. So let's bring this to the left. So let's subtract everything with 5 absolute x minus 3. All right, so 7. So just take this as x, right? So just write as it is again. So we know that this is going to equal 0, and then 7 minus 5 is 2, right? And then from here, before we can even open the absolute sign, we need to get rid of the 2. Because 2 is being multiplied to this, we're going to divide everything by 2. So now x minus 3 equals 0. Now we can open the absolute sign, right? So we have x minus 3 equals 0. 0 is not positive or negative, so we only have like just this one equation. Say like, but in other instances, maybe if like this is like 1, then you'll have x minus 3 equals 1, x minus 3 equals negative 1. But in this case, it's 0. So we're just only writing it like this, right? At 3, so we have x equals 3. And that's our solution. All right. And that's it for absolute value equations. Now, very last thing that we have in expressions, equations, and formulas are literal equations, right? So with literal equations, normally they would give us like a formula or an equation, like in this case, right? And they want us to solve for something. So in this case, we are given the formula. Let's write it out again. The volume of a sphere is known as V equals 4 over 3 pi r cubed. Solve for r, which means that we want our solution to be r equals something, right? So let's slowly untangle this. So let's get rid of the fraction first. To get rid of the fraction, let's multiply it by the reciprocal. So let's put a parentheses. We're going to multiply everything with 3 over 4. We're going to multiply this side with 3 over 4 because we did that. All right, so now we have 3 over 4. Let's write v on top. You'll see in a second y equals to pi r cubed. All right, now let's get rid of the pi, right? Because we want r cubed right now to be isolated, to be by itself. Because pi is being multiplied to r cubed, we're going to divide both sides by r. Divide both sides by r. All right, so that's going to give us 3v over 4 pi equals to r cubed. All right, let's rewrite it this way, just for simplicity's sake. All right, now we want to get rid of the cube, right? So the opposite of cube is going to be a cube root. So that means we are going to cube root everything. All right, so it's going to look like this. And so then finally our equation is going to look like r equals cube root 3v over 4 pi. And that's our solution. And that's how you do literal equations. You're just manipulating the things around so that you have the variable that you want, in this case r, to be by itself. Oops. All right, if you have any questions about this, I know it's a lot. Again, bring it to your deep dive lesson. Okay, have a good rest of your day.